quarter of that time as well as a programmer. I've shipped a lot of games. It might be more than 18 actually, but I mean, you know, who's counting? It just sounds, the number's big. I'd like it to be more than 20 because that's a better number, but whatever. I was a founder of a company called Freestyle Games. We invented DJ Hero, and the company's since sort of disappeared. It's now Ubisoft Leamington. There's probably only about 10% of the people there who were there when I was there now. But, you know, so I've done, you know, I've started games companies and done a lot of things. I've got a lot of experience. When we started Freestyle, there were 3 programmers and we basically did everything between us. And over time, as the company grew, I just sort of moved from role to role, doing whatever I felt like, because that's one of the joys of being a founder of a company. You can sort of do what you want to an extent. So I would say I'm sort of a technical generalist. Like, I've done everything from renderers to tool pipelines to, you know, fun stuff, boring stuff that works, basically. So the reason we're calling it How to Suck Less is because it's a complex topic, and anybody who tells you how to program is wrong, because they will think that they were wrong in 6 months' time, right? Like, you shouldn't trust anybody who tells you that there is a specific way to do it right and not a specific way to do. Well, there are lots of specific ways to do it wrong, but there's very few that you couldn't say there's a specific way to do it right for a lot of circumstances. So I think the best we can realistically achieve as programmers, when sharing our knowledge with each other, is to just literally do that. Say, oh, these are the things I did that did not work out well. Here's how I fixed that later. And so ultimately, we're just sort of reducing everybody's overall risk of all the programmers that we meet by sharing that information, and therefore everybody benefits, right? Okay. So the first thing that I need to talk about is sort of what software engineering is and sort of what the purpose of it is. I'd say it's not one of these, it's just one of these things people say, oh yeah, software engineering, and no one really bothers to sit down and say what it is or sort of explain. You know, it's like when people talk about quality assurance, I'm not in any way picking on QA because they get picked on enough, right? But when people talk about quality assurance, how many people sit down and define what quality actually means in the first place, right? So that's the biggest problem in some respects, is when we talk about software engineering, people just go, yeah, software engineering, right? So let's talk about what the point of it is. The point of it is risk, cost, and time. Oops. Yeah, we don't want Java to be updated. Shut up, computer. Risk costs us time costs us money, right? Whether that's just us working on our evenings on our own spare time projects, or whether it's a company we work for with hundreds of people, that is true. It's one of those things that everybody says all the time, and it's really dull, but it's absolutely true. So our purpose in software engineering is to minimise the risk that we expose ourselves and the company and, you know, potentially everybody else who we're working with too. But the problem is games are complex and they change during development. There's that classic thing that you get taught at university where you get a bunch of post-it notes and you draw out an object-oriented plan and you go, this is how we're going to make our software. Well, that doesn't work for games. Like, it won't get you past the first 5 minutes, basically. You know, if you don't do it, you'll definitely make things worse than if you do it, right? But it's still, the point is you can't just do a waterfall plan. People talk about this isn't about production methodology, right? But, you know, that whole, like, make a list of things and do them one after another till the game's done thing doesn't really work well for games. So what we're trying to do here with this talk is to just basically say, what's the sort of minimum thing that you need to be doing as a programmer to make your life easier and everybody else who you work with's life easier? All of these things, architecture, big picture architecture, you know, production methodologies, there's whole books on that. Other people have done lots of talks on it. You know, we're going to leave that alone. What we're going to do is we're going to look at a medium-sized problem, right? The medium-sized problem is somewhere between that meta thing. It's like, how do you optimize company-wide processes is one problem. How do you optimize, you know, small loops involved in rendering or GPU pipelines or, you know, just data access or whatever? Those are the two things people always talk about. Very few people ever get around to talking about this middle-sized problem in the middle. And I've seen a lot of code bases. Since I started Darbtron, I've primarily been making my money by porting people's games from PC to console, or helping people port games from PC to console. So I've seen a lot of almost shipped games in various states of brokenness, because that's how games always are when they need porting. They're generally broken in some respect. And almost all of these games are suffering the exact same problems, and they're all avoidable if you start off in the beginning without doing them, and if everybody takes responsibility to not make those problems happen in the first place. So yeah, I'm calling it a meso-level problem, but I mean, I doubt it'll catch on. So, oh, hello. Have we missed some slides? No, we haven't. That's fine. This medium-sized problem is particularly important when porting to console. There's a lot of things on PC that you can do and it's fine. which you just cannot do on console, and you will have to fix those things. And depending on how much of your game is built, you know, like all software is a stack of cards, right? You've got stuff at the bottom and everything else starts to rely on it. The further down that stack of cards, the problem is that it's non-console compatible, the bigger the problem it will be for you when you try to port it. So following principles from this talk will help you avoid those things. It won't prevent them, obviously, because the only thing that can prevent them is having done them before and knowing how to avoid them. So how do we end up in this state where we've got nobody ever sat down and went, oh, we need to make a broken game, but the game's horribly broken, right? Well, the main reason is just constant deadline pressure, right? People are going, you've got to have that thing done next week, tomorrow, you know, in an hour. And so people take shortcuts, and people very rarely have the time to go back and fix those things, right? Until it gets to the point where you're trying to master the game and everything's fundamentally broken and you're not going to be able to ship. So, and the other thing is, it's not even, these problems aren't in engine software. Normally, they're almost always in game architecture. So, and the big problem with this is, like, I've worked with a lot of programmers, you know, with 20 odd years experience who are still doing these same stupid things that you can look at their code and go, oh, why are you doing that? I mean, I'm talking about myself 6 months ago, right, as well. You know, I don't think there's any programmers who don't look back at code they wrote 6 months ago and think, who wrote this? Oh, it was me. Okay, yeah, that's stupid. You know, that's how it is, right? So the takeaway, as I'm rapidly trying to accelerate through this, because this talk was originally 45 minutes when I gave it previously, so hopefully I'll be able to get through to the good bits quickly. But it's sort of important to give you a why we're doing it. The takeaway is sort of what I like to call minimum viable software engineering, and it's not a thing, it's like a bunch of principles, right? And I just want people to talk about it with each other and discuss it and say, I did this thing and it was really helpful because what we're trying to do is we're trying to produce code that doesn't have too much architecture but has some, right? That if we need to change it, it makes our lives easy to change it, but it also protects us from our own stupidity to some extent. So, you know, these are things that I've learned by just fixing other people's broken code bases a lot of times over 20 odd years, right? So hopefully you should find them useful. The main thing is this, right? Just to proactively reduce risk. Like if you see something that needs fixing and you think, well, that code's bad, we should fix that. Don't just put a comment to do, fix this code later. Just fix it, right? Like it will make you take longer, but you know, eventually you will see the benefits. Okay, yeah, I've already covered that. So when I've given this talk before, I've deliberately made the talk shorter so that we could have some dialogue with the people listening to the talk. So I don't know whether we're going to have time for that, but since it's lunch straight after, if I whiz through, we should have time for Q&A. So, but you know, if there's something really big or you think I'm talking nonsense, feel free to call me out on it. You're probably wrong, but you know, that's fine. So our guiding principles are take responsibility for your code. Because once you put it into source control, you are going to have to live with it, right? The number of games I've worked on and engines I've worked on where we wrote some font code just to get the font rendering working, and then 10 years later, that same janky font code was at the base of all of our UI code, still had that same janky font code. It's just a thing that happens, right? Because if it works, people will live with it. And the worst thing about that is once people have started to live with your janky code, the longer that's gone on for, the harder it is to fix it, because the more places it's permeated into, the more people have made changes to it, thinking it didn't do what they wanted it to, and bodged some other mess onto the side of it. So, you know, you have to live with stuff. We're aiming to maximise like the robustness of our code, the ease of other people understanding it. This is like super, super, super key important, because not only is it other people, it's also yourself in the future. Okay, but in a team environment, this is the most important thing. You should be optimizing for the ease of understanding your code, not optimizing for speed as your primary thing that you do in your day-to-day job. Okay, and making things easy to understand also generally makes them easier to change, and it means that other people coming into your code will be able to debug it more reliably. Okay, because one of the big problems, especially when you're trying to master a game, is that everybody just gets given bugs and you'll be fixing bugs in other people's code. If other people look at your code and go, oh, I think I know what's going on here, bash, 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 and they fixed it wrong because they didn't bother to take the time to understand it, that's as much your fault as the person who wrote the code as it is their fault for doing it badly. Well, it's mostly their fault, but you know, you can make it less likely to happen. But ultimately, the big thing we want to do is we don't want to slow you down, right? If you're going to take an extra 5 minutes here and there, that extra 5 minutes has to work out as a net gain in time from causing less bugs or something. So this is my thought for the day. All problems in computer science can be solved by another level of indirection, except the problem of too many indirections. So You know, this is sort of the primary tool in your arsenal, is putting a level of indirection around pretty much everything. Okay, David Wheeler was a legend. He invented function calls, and originally they were called Wheeler jumps, but he's dead now, sadly. I never met the guy, but I mean, he might have been an awful human for all I know, but he invented function calls, and that makes him cool in my book. Okay, so I'm going to ask a question, and this is one time when you definitely should feel free to respond. I have an opinion about what the most dangerous thing in every single code base is. I would like other people's opinions. So does anybody... Hello? What, in a code base? How'd you get one of those in a code base? Oh, okay. Well, so, okay, if it was possible to have active shooters inside your code base, they would be quite dangerous. Anybody else got an opinion? Well, yeah, definitely. But then you could say that of yourself, right? You know, I'm just as dangerous as any other programmer, pretty much. Go on.
Changes to the code without documenting it?
Maybe. No, probably not. Well, I'll tell you, well, I'm going to put you, go on, there's someone else.
The semicolon?
Oh, you're getting closer to what my opinion is.
Temporary fixes. Right.
What?
Temporary fixes.
Temporary fixes, well, yes and no. Like sometimes, yeah, you do. But I mean, that's a bad thing. Go on, someone said, nearly. I'll tell you what the answer is, the equal sign. Right, this is pretty much the cause of every bug in your game. Pretty much the cause of every bug that ever crashed a game, the equal sign, right? So what's the relevance of that? Well, so the relevance of that is mutation. I don't mean like X-Men. I'm talking about changing the value of a thing. It's a dangerous thing to do, right? It causes crashes, right? So this is going to sound ridiculous. This is the fundamental principle underlying why accessors should be something that you do for everything. Even like if you've got a class and you've got private member variables, use accessors within your own class. You might think, well, I've got to type brackets and like a function name. And it's like, okay, yeah, but sooner or later, you're going to come to a point where you need to know what's setting that thing, right? And you can put a breakpoint in the accessor, or you can put 50 breakpoints everywhere it might be getting set, right? Or you can put a log in the accessor, or you can put 50 logs everywhere it's getting set, right? So this is danger. So if we can reduce the number of equal signs in our code, we're definitely reducing bugs. I'm not even talking about theoretically, we're definitely reducing bugs. Statistically, the less equal signs there are in your code base, the less bugs you will have, right? Or at least the less specific lines of code causing bugs, right? But so this is one thing I say is, but basically like put equal signs somewhere where you can isolate them and track them down if you need to, right? That's the first thing. Is like I'm telling you, this genuinely has saved me more time than any other thing that I do. Is just being really anal about using accessors. Okay, so and this duplication is an extension of that, right? If you're putting an equals in multiple places, right, then you're essentially duplicating code. So any duplication is also statistically a bad idea, because if you've got the same line of code twice, or the same copy and pasted block of code twice, if there's a bug in that block of code, you then have to go and find everywhere you copied and pasted it to, or find everywhere that you did that same idiom of code. Right, if you put it in a function, you've only got to find it once, and you know that that function is the place where you're fixing the bug. Right? Accessors are like a subclass of this thing. Pretty much any time you find yourself copying and pasting a bit of code from one place to another, just write a function instead, right? It won't take you that much longer, and eventually it will save you time. But there's another thing about this, is that copy and paste bugs are an actual thing. Someone did a study. I should really have put a URL in the talk, but there's a thing where it's provable that pretty much if you copy and paste the same chunk of code like 4 times, you're something like 80% likely to miss something in that last block and have it accessing the same thing at either the third or the second or the first block did. Your code will compile and it will run, and you'll be like, rad, my code is working, right? But your code is broken, and in future you will hate you for doing that. So always think about how much you don't want your future self to hate yourself, and that's why you should write functions, right? So this also falls under like another principle of this minimum viable software engineering, which is abstract anything that's likely to change, right? So for example, if you're calling new in any code, like C# or C++ or any, you're essentially asking for memory from somewhere. Now, if you want to change where that memory is coming from, if you've called new everywhere, you have to go and overload global operator new or something, right? And that might be inconvenient, or you have to overload because the simplest thing to do is just to wrap every call to new that you make, and then you can just change what the wrapper does later if you need to, right? That one little thing will save you, and I know I've got friends who work at Rare, and I may be wrong about this, but they told me that they're not allowed to call new at Rare. Like there's library calls that have got new in and you're not allowed to call it yourself. Personally, I think that's a brilliant idea, because, memory management causing problems with memory is one of the biggest problems generally. Anyway, so whatever. The point being, abstract anything that's likely to change, right? And functions are the minimum amount of abstraction you can have, sort of. Okay, so the next big problem is object state. So we've all seen some code that, again, has probably been flung together in a hurry by several different people, where you've got an if-else statement that's probably bigger than this, right, seen on a regular size monitor. So everybody's seen one of those. The problem with those is the if-elses are intrinsically awful because each of the sets of brackets in the if-else has got an implicit reliance on the other things failing before it gets there. So it means that it's really hard to fix bugs in other people's code that uses big if-elses. They're brittle. If your same bit of code needs to check broadly the same thing in more than one place, someone's going to have copied and pasted that check in like 4 or 5 places, right? Which means that it's probably, if you find a bug in it or you make a change, you're going to have to find all the places that check was done and fix them. Don't do that. Have one function that sets a state variable, which is an enum or something, from one switch, from one if-else that's horrible, one place. And then from that point on, you just check the enum and every bit of code is safe. Right? Again, we're sort of reducing the places that we're doing the same thing. It's reduce of duplication, it's reduce of mutability. Generally, I use switch pretty much everywhere I would use if. If it's a constant that can be compared against a constant, then I will just use a switch. I almost never use ifs for that sort of thing. There's a lot of benefits to that. One being that like you can handle a specific case and have every other case hit the default. Or if you've got like an enum and you want to add a new state to your thing, but then you forgot to handle it in one place, if you put like an assert on the default, then it will guarantee that if you forget to add the code you should have added, you'll hit an assert. You won't just think your code's working, right? So these are sort of useful things. But these giant if-elses, the problem with them is they started off as an if, probably, that someone wrote, and then someone else came along and went, oh, I need to check for something else, I'll just put an else on the end of that. Someone else came along and went, oh, I'll just put an else on the end of that, I can't be bothered to make it an enum. 6 months later, everybody's living in fear of touching that code in case it kills the whole game, right? So this is why you should do it in the first place, right? As soon as you go beyond an if, think, is this actually like a state of the object thing that I'm checking? If it is, make it an enum. Okay, so the next thing is sort of interface and responsibility. I mean, this is a standard, like you'll see this on, go to Google, how should I do object-oriented programming, and they will put separation of responsibility, like, you can find that out for yourselves. But the basic thing there is if you're writing a class, again, another thing that you'll have seen in every code base is one class that starts off doing a thing, and someone else can't be bothered to make a new .h and a .cpp, so they just stick some new functionality in that class, and before you know it, this one class does like 20 things. All the member variables are just like used willy-nilly. You don't really know what's changing anything. Like that's another argument for using accessors, right? It's sort of inevitable that you will grow 1 or 2 monster classes because sometimes there's not an obvious way to split them up. But when you do it carefully, right? Put all of the, I would suggest like taking all of the functions that do one thing and putting them together in one bit of the class header and another bit in another bit, so that when you do come to refactor it, you can just pull it out and drop it in somewhere else. But so that's, responsibility, that's a tricky thing, but that's like the biggest problem. Like in the last week, I've probably wasted like at least a day because I made bad decisions about what thing was responsible for what. And this is like really boring UI code that, nobody wants to do. But if you get it wrong, it can cause you an absolute nightmare, right? So it's important to do it properly in the first place. So this top one, enum versus bool. The number of times I've seen code where we've got like 4 flags, like B is touching ground, B is running, B is holding like ball or whatever. If those things are mutually exclusive, don't have them as flags, right? A lot of the time, character state or object state, they are mutually exclusive states. If you've got more than one flag and they shouldn't ever both be true, make it an enum, just test the enum instead. Right? Bools, not only is it's because you've got more than one variable that's controlling essentially one state thing there, that's a problem. But not only is that bad, but bools are intrinsically difficult to understand, right? You're relying on people being sensible in their naming. And we've all seen code that's like, if not the thing is not switched on. And you're like, what does that even mean? Like if you've got an enum, it just literally tells you what it means, right? Whereas with a bool, you have to think about what the logical negation of someone else's idea of a sensible name is, okay? So don't use bool unless it's literally like, is this thing true? And it can only ever be yes or no. And you know for a fact it can't possibly go beyond that. Put a bool on it. And even then, I often just use an enum for just 2 state things because then the code's easier to read afterwards, right? Like I say, enums are better intrinsically because you can give them sensible names instead of true and false. Okay, so we've already talked about refactor now, not later. But if you come across a class that's got more than one responsibility and the code can be easily refactored, just do it, right? It's not that big a problem. I mean, it does depend on the code base that you're in. I know when I was working in sort of AAA, it was a lot more onerous to add an extra CPP and H file, and it carried more risk for accidentally breaking something than it did if you just shoved it in another existing file. But you should do that, I think. Personally, I just try to do that in my own code. Now that I'm working for myself, I'm just like, right, I'm going to do this. I never leave it. I'm assuming most people are familiar with the MVC sort of separation of responsibility thing. This, for games, is surprisingly frequent, how pretty much everything in a game falls into MVC. Character controllers for animation, UI stuff, basically everything. So I'm not saying make things, call everything model and view and controller. I'm just saying like that's a useful lens. Like in many ways, it's more useful than other patterns because it gives you sort of like a specific structure to look at it from. So, the other thing is if you don't have time to do it properly, then you should at the very least have like an internal bug tracking thing where you keep track of all the bad things that you've done, not just to do, like literally go and add a bug, I did this bad thing, it must be fixed, right? Then that way everybody knows, you can sit down like once a month and go, okay, let's have a bug fixing day or whatever, make this stuff right. I mean, I've got a Trello board for my own project that's just got one column of things that I've done that I shouldn't have done, and every milestone, the first thing I do is I fix all of those and then I carry on with the next work. So, here's the thing, lifetime and scope. When you're trying to master a game, lifetime and scope of things, when we're doing with memory management, running out of memory, loading data, saving data, all of that sort of stuff, the control of the lifetime of those sort of things, especially if you're trying to get something to work in a console which has got a fixed amount of memory or has got very specific ways you have to load and save data or whatever. One of the biggest problems is just managing that lifetime explicitly. So one of the things that happens here is that lazy initialization, which you will see is like the default way of creating pretty much everything. Like you go on internet and go, how do I do this thing in Unity? And then someone's written like a lazy initialized class. Or in fact, if you look at probably most engines, the person who wrote them, oh, lazy initialization is good because if you don't use it, you don't pay the cost for memory. Like it's not, it's super evil, right? And especially it's super evil when it's involved with singletons as well. So the number of games, so I'm talking from personal experience, like singletons themselves are not fundamentally evil. It's more about how they're used, how they're accessed and how they're created and what you do with them. Okay, because really a singleton, everyone says global variables are bad, don't do that, but everyone's happy to have a singleton, which is basically a global variable wrapped up in a class to make it look like it's nice and not a global variable. But say the number of games I've worked on where globally accessible singletons have been the root cause of some horrible architectural problem that basically took a fortnight to fix the day before we were supposed to ship it. And I do mean that, like I've worked on games that have release dates have been put back because of dodgy singleton patterns being used in them. Because if you do lazy initialization, right, well, let's step back a bit. You're trying to get a game shipped, right? So you want to know when things are being allocated in memory, when things are being deallocated. You want to have complete control over that. Lazy initialization basically says, don't worry about having a specific order. If someone tries to access this thing, build it there and then, right? Oh crap, I'm already over time. Okay, but the bad thing about this is if someone makes a small change to the code that touches that singleton, like a frame earlier or a tiny bit earlier or a tiny bit later than they were doing, suddenly your memory layout of your whole project can go wrong. And when you're trying to ship a game, that can be days of slippage, failing certification. It could be any number of things. So just be really careful. Always use explicit creation for memory allocation. Right, so since we're basically at the time we should have stopped and I've still got nearly 10 slides left, I'm going to whiz through these things. And if you want to know more, you can stop me and ask me. Or I'm hoping Kirsty from Yuki said that she was hopefully going to put the slides on the internet somewhere. I'll share them on Twitter in a bit if I haven't already. So we'll do that. But I'll whiz through the last few slides anyway. There's, I think, quite a large proportion of them are jokes, we shall see. I can't remember. So the next thing is make everything asynchronous. Right, this is easy to do when you're writing code for the first time, right? Don't open a file, save your save data into it and close it in one function. That will not work on consoles, right? You should emulate asynchronous, because you might want to make it a cloud save, right? Anyway, like you want to save to Steam's cloud save or, I don't know, somebody else's or write your own. Anything across the network, anything that's talking to system resources on a console, and a lot of other systems, is asynchronous. You say, please do this thing, and then you wait a little bit of time, and eventually it gets back to you, like several frames later, usually. It's easy to make synchronous code behave asynchronously, or you just wrap it in a little class that doesn't do the thing straight away. Do that straight away, because otherwise you will definitely have trouble getting stuff done. Like anything to do with console certification, pretty much on all 3 platforms has asynchronous function calls in it in places that you won't have them if you've just written it on a PC, right? So save games have been the main one of those. User login and all that sort of stuff. Anything where you might need to interface with an operating system, you should assume it's asynchronous, right? Okay, so porting to consoles. These next few slides are just really like, you know, if you want to port stuff to consoles, like send me an email. I've done a whole talk about how to port things to consoles, so I've definitely put that on Twitter before. I can put that up as well. The main things you have to worry about are multiple users and controllers. You don't generally have to worry about that on PC. Everything's asynchronous. There's a lot of specific game flow behaviors on console that if you don't do them, your game will fail, right? So you should find out broadly what they are and try and do them before you, when you're making your PC game, and it will make things a lot easier to port them. And also, online multiplayer is easy on PC, right? Doing it on console is no harder to make it work, but passing the requirements for what happens when you unplug a network cable, or if someone drops out, or if someone's chat headphone thing gets unplugged, is a lot of work. Like, it literally doubles the porting time of a port, just putting online multiplayer into it when it was already working in the first place. So it can be. Engines working on a platform are not the same thing as it being easy to port to them because of requirements. Some, like Unreal handles more of it for you than Unity does, but yeah, you should expect to be spending a lot of time fanning around with that stuff. Yeah, so the prompt directive is track your user, your controller, and your save data, right? And then when your gameplay, you've got to worry about initialization, resetting, and shutdown. Be like supremely retentive about that, right? And you also want to be able to, stuff like receiving an invite, or you think, oh, that'll be easy. But what that means is you've got to asynchronously receive that data. You've then got to like shuffle your entire code base around, navigate the front end automatically, a load of stuff that you wouldn't even have thought you had to do necessarily. So like you do that up front, it will be much easier. Okay, right, more porting stuff. We'll put that in a slide. So like the final thought, quickly before I finish, is that this is a good way to, and it's genuinely a thing. We started as a joke, me and a bunch of friends who are programmers, who've known each other for a long time. But what the flips per minute is a genuine code review metric. Basically, you're looking at someone else's code, including your own, right? You'll be like, oh my God, what's that even do? Oh, that's stupid. Why would you do that? A little bit more thinking, you might think, oh, that's fine, right? If you don't think, oh, that's fine, that's a bad thing. That's a genuine what the flip. You count those, and you give the number of those that are looking through someone else's code per minute, and that's a rough metric. We found that it works. We tried it secretly on other people's code, and we all came to broadly the same conclusions based on this metric, so it's good. Okay, so last slide. Take responsibility. That's the main thing. Don't duplicate code. Localize where you change stuff. Be explicit about state and what things do. Try and have exactly one responsibility per class. I mean, this is standard object-oriented stuff. Assume everything's asynchronous. You need to do that, or it will be troublesome. And don't put off refactoring. Right, and the last thing to remember is if you put it into source control, you have to live with it probably for the rest of the project, if not longer, right? So if you put bad code in, don't do that, it's bad. Okay, we haven't got time for questions, right? There's a load of people waiting to eat, which I didn't realise would be happening. So I'm going to apologise to those now. Sorry, people who are waiting to eat. Okay, that's me on Twitter. If you follow that, I'll post these slides like straight after this. So thank you for listening.